Hi, kids. Hey, I'm gonna talk to you. Just give you a real short instructional thing about Newton's second law. Newton's first law, if you remember, an object in motion stays in motion, an object at rest stays at rest, unless it acted on by a net outside force. So, like, if there is no outside force, then there's not going to be any acceleration. But Newton's second law says, well, if there is some outside force, if you add all the forces up and you get something besides zero, then your object is going to accelerate. And hopefully you guys know, hey, the rate of the acceleration depends on the mass. Now here's the weird thing. Okay, if you look on your formula sheet, because everybody knows, like, hey, F equals ma. You guys know that. But here's the weird thing. If you look on your formula sheet, you see the formula right. Yeah. Okay, they have A equals F over M, which is kind of weird. A equals the sum of the forces over M, or A equals the net force divided by M. Here's what I think is the reason why, and this is really the key to all Newton's second law and Newton's second law problems. That I think what this is actually trying to tell you is this. Hey, you know what? And they actually had little vector symbols here to remind you, hey, it's a vector, it's got direction, direction's important. But here's what this is actually telling you. The direction of the acceleration depends on the direction of the net force. So whichever way the net force is pointing, that's which way the acceleration is going to point as well. And that's really kind of the key to Newton's second law. So when you're doing any problem at all, any problem, every single problem, it's the same steps. You draw your FPD, you write your equation, or sometimes equations if there's parallel and perpendicular stuff. And then you plug stuff in and solve, okay? Sometimes if there's two bodies, you have to draw two free body diagrams. And you have to write multiple equations. But, like, the steps are always the same, okay? So just keep in mind, even if I do something simple like, hey, I shoot a ball, okay, through the air. Well, while that ball is moving through the air, that's my FPD. Guess what? It accelerates down. Guess what? It accelerates down at a rate of 9.8 meters per second squared. It's always the same. Like if I have something, a block that's going to be sliding, I don't know, we'll say down the incline, okay? That this is which way it's moving. Now careful. It doesn't mean it's accelerating that way, okay? Remember, motion acceleration could be very different. But if I was to draw my forces, okay, that let's say there is friction, force of normal, force of gravity. Well, I would have to add those forces up and then find the net force, and then the net force points in the direction of the acceleration. So like in this case, it would kind of depend on if I was to draw in my components, is this bigger than this? Okay. If this is bigger, then guess what? Okay, it's going to be accelerating up the incline, and you should write your equation, FF minus this, because that's which way, the net force points up the incline, then it's accelerating up the incline. But honestly, guys, Newton's second law problems, just keep in mind, net force points in the same direction as the acceleration. If you need help on any particular type of problem, for example, friction or inclines or elevators or whatever, then you probably want to watch one of the other videos. But I did want to give you that general overview. Bye, kids.